Hi everyone, I'm Adam. In this problem, for the given equation of our hyperbola, which we have as x squared over 25 minus y squared over 16 is equal to 1, we're going to be finding the center, the foci, the vertices, and the eccentricity. And then after that, we're going to sketch the graph using our asymptotes as an aid. So let's get started with using kind of the standard form of a hyperbola as our guide. So we have, namely, an x term minus the y term. So the negative is between x and y. So our standard form can kind of be generalized like this, something like x minus h squared over some constant a squared minus y minus k squared over some constant b squared, and that's equal to 1. So what that's going to tell us, so writing what we have in our standard form, that's going to kind of help us find our, at least, vertices and our center. But let's go ahead and write it first. So x squared can be written as x minus, say, 0 squared, and 25 can be written as 5 squared. So minus y squared is y minus 0 squared over 16, which is 4 squared, and that's equal to 1. So again, how does that help us? Well, our center is at the point hk. So if our h and k are 0 and 0, well, that means our center is at 0, 0, or namely the origin. So there's our first thing we have to find, our center. Let me come over here, and we'll just go ahead and plot that in to start with. So our center, point at the origin. Now, one other thing is that tells us about this hyperbola is the negative being on the y. We know that the transverse axis is going to run horizontally, and it also runs through the center point. So that also tells us the center point being at the origin, our transverse axis is going to be our x-axis, or the line, say, y equals 0. And that's going to help us out with our vertices in just a moment. So going a little bit out of order, we found the center. Next, let's find the vertices. So looking at the vertices, we look at our a and our b from our standard form. We have a is equal to 5 and b is equal to 4. So we find the vertices by going from our center point along our transverse axis up and down a unit of a. So from our center point, going up 5 and down 5 on our transverse axis, that's going to give us where our two vertices are going to be at. So our two vertices are going to be at the 2 points, say at x equals -5, 0, and y equals +5 and 0. Okay, and so next let's go back and find the foci. So our foci, that's kind of the same as finding the vertices. From our center, we're going to go up and down a unit of c, where what is c? C is a constant that has the relationship where c squared is equal to a squared plus b squared. Well, and we know what a and b are. That's equal to 5 squared plus 4 squared, so 25 plus 16, so c squared is equal to 41. So solving for c, taking the square root of both sides. Now c being a distance, we're going to take the positive square root. So c is going to be positive square root of 41. So our foci, again, from the center going up or down by a unit of this. So our 2 points are going to be at negative square root 41, 0, and positive square root of 41 and 0. Now in sketching the graph, we really don't need these today, so I'm not going to plot those points, so we'll leave them as they are. So we have our center, vertices, foci. What else do we have? Our eccentricity. So let's find our eccentricity. So how do we find the eccentricity? Well, the eccentricity is the number e, which is simply c divided by a. So we know what our c is. So our c is the square root, positive square root of 41 divided by a, which is 5. Okay, so that we have that in exact form. Color. Okay. So we have all the in particulars that we need to define. Now we're going to go ahead and try and sketch this. But first we said we're going to find our asymptotes and use those as an aid. So the asymptotes can be found by the line, say y equals, or lines, y equals k plus or minus, say b over a times x minus h. So we actually have two lines here. So filling everything in, we're going to have y equals, now our k, going back to the center point, is just 0. So we're going to have y equals simply plus or minus b over a, or 4 over 5, times x minus h, or just x minus 0. And we'll just clean this up and write these as two separate lines. So we're going to have the two lines as our asymptotes, say y equals negative 4/5 x, and y equals positive 4/5 x. Okay, so using these two lines, we're going to plot these in here. All right, they're going to be kind of going crisscross through the origin, and then we're going to plot our hyperbola. So let's sketch the lines, and then we'll sketch in our hyperbola. So first, well, let's look at the line y equals negative 4/5 x. So starting at the origin, kind of going, say, down 4 and over 5. We're going to plot a few points just to help us. And then from the origin, say, going up 4 and over to the left 5, using our slope. So our one asymptote would be a line about through those 3 points. More. Okay. And also the line y equals positive 4/5 x. So plotting in a few points from our origin, going up 4 to the right 5. Get 1 point here on that line. And from our origin, going down 4 and to the left 5. Get another point, and sketch our axis or asymptote there. Okay, so there we go. Now to finish it up, we're going to sketch in our hyperbola. So our hyperbola is going to exist between these two asymptotes. Right? Here's our transverse axis going through our vertex. So we're going to look something like this, coming from our vertex, going out, following along our asymptotes, and the other side through the vertex, following along the asymptotes. And there we go. So hyperbola looking something like that. Thank you very much.